So we can talk about our random variables essentially as falling into one of two categories, either discrete or continuous. Where when we're talking about discrete random variables, we are talking about things that occur finitely or countably many times, and we're making measurements like counts. So if you want to talk about something that is discrete, you can talk about the number of homework assignments that you complete in a given week. Whereas for continuous things, we're talking about measurements that have uncountably many values that sort of can be seen as existing along a spectrum of possibilities. So if we have that discrete count of assignments, we could say we have a continuous measurement for the amount of time spent in total on all of them. And in general, that's the sort of distinction you can make in between whether you take a discrete number, fixed points, 1, 2, 3, 4, 5, or a continuous slide in between, like so, where another way we can think about this is if we go to the store and you want to buy onions, you can buy one onion or two, or if you really need a whole bunch of them, you can get a whole bag of onions. But when you're talking about buying them, you're very well not going to go to the store and chop an onion up, take only the pieces you want, and throw the rest back in the bin. You get kicked out of Target for doing that. You can only get a discrete amount of them. So you can think of these discrete things as just being the points. It's just a count of the amount of the thing you have. Meanwhile, for continuous things, we could think about the fact that when we're buying those onions, you probably want them for a specific recipe, and that recipe might ask you to have them in terms of a volume or mass or weight, because not all onions are created perfectly equal. So, if you want to get the weight of your onions, that would be a continuous measurement, because you have any possibility along a spectrum of options there, a complete set of possible things that you can do with that value. Anything's possible, and you have all the options you possibly need to get the exact measurement you want. It's not just a count, it's a full spectrum. And to see this a bit more, we'll look at a couple more examples. So here we want to determine if the following are discrete or continuous random variables, where our first is we're going to let X represent the number of Fortune 500 companies that lost money in the previous year. And for the second, we let X represent the volume of gasoline in a 21-gallon tank. So remember, just like I said in that last video, when we're talking about these random variables X, it's not really anything all that special or weird or different. It's just a shorthand. So you shouldn't go running away at the sound of X because it means math is coming. It's just an abbreviation to say, here's what we're talking about, because that list of things, like the list of Fortune 500 companies that lost money in the last year, might not be very short.
Okay, and this fair share is a bullshit concept. It's just a way of attacking wealthy people, and
so we just want to condense it all down to one letter. Anyway, for that first case, because the number of companies would be a count, you have one company on the list, 2, 3, 4, however many it would have been. This would be a discrete variable, because you can't have half of a company on that list. It's either there or it's not, and either it lost money or it didn't. So it is discrete, because you're just counting them. Meanwhile, in that second case, where we're talking about the volume there in that 21-gallon tank, well, there's nothing that says it has to go from 21 to 20 to 19 to 18, 17, 16 until you all the way get down to 0. Anything in there is possible, although you might not technically be able to see it down to the level of specificity that it is. But because any value from 0 to 21 is possible because we have a complete spectrum of options here. This would be, should be another N in there, continuous. This is a continuous measurement. So now that we have a sense of what it means when we're looking at these random variables, when we're looking at those X values, we're going to talk about how we can turn them into nicer representations in terms of things called probability distributions.